And we should be live, I hope. Good evening, everyone. Hello, Harul. Hello, Severio. Okay, no, I'm not starting on full camera this time. I don't want to risk forgetting to turn it back onto the desktop. So we're just starting with this. So tonight we don't have a whole lot to talk about as far as things happening in the past week, because work has kept me busy, and I've had very little time to spend on Godot this week, unfortunately. But you know, that's life, I guess. Sometimes you get a little bit busy with things, and work comes first, unfortunately. So as far as this is still a hobby for me. So I hope everybody's having a good week. I hope everybody is doing well concerning all the things going on in the world. Let's get into some game development. So last week we left off with implementing the basics of the AI of our NPCs so that they can actually fight back. I think there's a lot of room for improvement there. It's very simplistic. They don't act very natural yet, but you know, considering that we did it in one night, I am still pretty happy with the result because all the basic ingredients are there now. So tonight I really wanted to spend a bit of time looking at improving. Hold on, let me see. Yeah, I've got that one in the right spot. Hey SSLX, how are you? Yeah, phone VR is I'm not a fan. Not a fan at all. Actually, let me catch up on everything that's being discussed before the stream even started. So Rahul is saying that he wants a VR set for game development purposes, but he's currently using a MacBook Air. And Safaria is wondering if a MacBook Air is powerful enough for that purpose. And indeed, yeah, MacBook Air is quite lightweight. You could, you know, if you have a Oculus Quest, you could perfectly do Oculus Quest development on a MacBook Air because all the stuff is running on your Quest. That's actually a really good combination. So that might be something to consider. But if you are looking at getting a much better computer and with that a much better headset, depends on your budget. I am using an Index for most of these streams, which I am incredibly impressed with, but it is one of the high-end headsets with also a high-end price. So you need to be willing to spend that sort of money, especially if you've just spent a whole bunch of money on a very powerful PC. My recommendation that I am giving most of the time to people who ask me is to go for a Rift S because of the price difference with the Index. And as a developer, I actually prefer the Rift S. As a gamer, I prefer the Index. But you know, they both have their pros and cons. And one of the biggest pros of the Rift S is that you can use it anywhere because it has inside-out tracking, and it's the easiest headset of almost all the options to constantly be taking on and off. So that is something to keep in mind. You know, when you're developing games, you're constantly taking the headset off, putting it back on, taking it off, putting it back on. And it's really only the MR headsets, especially the flip-up ones, that I like more in that respect. The big problems with the MR headsets is that the controllers really let you down. So yeah, the Rift S, as far as development is concerned, I'm a big fan of the Rift S. Yeah, Google Cardboard is pretty much dead. It was fun, you know, to get into VR. Yeah, you can do some nice little things, but it's actually, when you look at what they do with it in China, especially where they do a lot of 3DOF applications for people to use when they're commuting on the train to work or back home. There's a big market there for that sort of thing. But when you look at real gaming, the sort of thing that we're doing here, yeah, cardboard is not good enough, and any sort of phone solution I'm not a big fan of. Even the Gear VR, which of course coupled with a pretty good Samsung phone, it's fun as a starter set, but you've got, you know, especially when you think about it, your phone is $1,000, you know, so depending on what sort of phone you go with. So for that sort of money, you have a really good VR headset, especially considering, you know, or assuming that you have a good computer to back it up. I have no idea whether I am going to move this over to Godot 4 or if I'm going to keep it in Godot 3. That really depends a lot on time, to be honest. And the biggest holdback right now is that there's still a lot to do to actually make VR work in Godot 4. We're probably going to spend some time seriously looking at OpenXR. There is an OpenXR driver now. I've been trying to get it to work on Windows, but time has not permitted me to take the last steps in that. It's almost working as a base principle. But with OpenXR, it'll be easier to start looking at. Okay, let's complete that first because it supports the most headsets. You know, because all the major vendors now have support for that. Oculus has got their drivers out. Valve has got their drivers out. Microsoft has had the drivers out for ages. So provided that obviously your system runs Vulkan, that is probably the way forward. But right now, time is incredibly limited. So I don't know whether we're going to have that ready in time for this particular project, or if I'm going to be too far along with this project and I don't want to refactor things into Godot 4. I don't know right now. The other thing, as I said in my previous streams, is because of the type and nature of this game, because of the lighting requirements for, you know, a space fighter game, there isn't a lot of benefit moving from the current solution to a Vulkan-based renderer. Because, you know, all the beautiful things that John is demoing right now that he's all been working on for the past couple of months, you know, the new dynamic GI system that he has and the fog system and all that sort of stuff, it doesn't really apply in space. I do like the volumetric lighting. That might be nice in a space game, especially when we look at our current test scene with the sun in the background and the asteroid field having volumetric lighting shine through the asteroid field. That could be a really cool effect, but whether that is enough of a reason to switch, I'm not sure yet. We might not. It also depends on, you know, how long it's going to take to get this to a point that I'm really moving it forward to building a full game. It might very simply be that, you know, we're going to be busy on this for a year or so. You know, by that time Godot 4 will be out and everything will be ready. Then I will probably somewhere down the line of development switch to Godot 4 and start using the new features. But at this point in time, the plan is to stick with Glass 2. All right, so yeah, so I was talking about tonight. I want to give the AI a rest for one night, mainly also because I want to spend some time researching some more things to see if I can come up with some more ideas of how to improve it. Maybe work some things out on paper first so that we actually have a plan moving forward. So far we've been winging it, but we're really getting to a point of the AI logic where we really need to plan things out and sort of say, okay, this is how our enemy NPC is going to behave. This is how he's going to behave when he's flying around. This is how he's going to behave when he detects me or one of my friends. This is how he's going to behave when he's being shot at, all that sort of stuff. So there's going to be better trigger points, and I might refactor a few things that we've built so far. You know, again, you know, the last 2 weeks have really been exploring something that I have never done before. I've never written AI for a game before. I've always been busy with rendering and that sort of stuff. So so far it's been very interesting, but I want to do a little bit more research before I take the next steps there. So one of the things that we've been missing while we're fighting is that we don't get, you know, we added some particle effects for when we hit stuff, but we're missing a bunch of things in the UI to make it easier to shoot at things. The other thing that I really wanted to spend time on first is I want to do something with the shields. So I want to visualize when we hit the shield. I want to do something when the shield goes down, that you get some sort of animation of the shield going down, and I want to do some sort of animation when the shield comes back up. That's something that we haven't worked on yet, but I want the shields to be regenerative. That when you take the shields down, the shields slowly power back up and eventually pop back into existence. So that is something that we are going to to look at today. Will you public full game on Steam or another platform, or is this what it's just tutorial project? Sorry, I needed to put that into line. Yeah. This is not a tutorial project. Being very clear from that from the start. The end goal of this, if we get far enough down the track, is this. I want this to be a game that I can eventually put onto Steam or itch or Epic Store or whatever I decide when we're ready to do to make that step, to actually make that available and potentially even sell it. But that's very far ahead. Now, what I have said in the past is that I am looking at options and open to suggestions to at some point make the code of this project open source. Again, as I've said many times on this stream before, anything you see me do here, any code that you see me write on stream is, as far as I'm concerned, completely public domain. So obviously you'll have to copy it off of what I'm writing on screen at this point in time, because I don't have a repository up publicly. The thing that is holding me back from open sourcing the project right now and making it available to everybody is simply because the assets that we're using and eventually all the content of the game, the storyline and all that sort of stuff, that stays within copyright because it's copyrighted by the artist who developed the or who made the assets. Eventually the storyline is going to be part of the game that we're selling, but the code that I write is something that I want to share with everybody, and also one of the reasons why I'm doing these streams, on one side to be motivated in doing this, but also to show how to potentially approach some of these problems. So yeah, so I am still looking at, okay, how can I purely publish the code part of it? Because also, of course, if I publish the code part of it, it'll be a non-functional game. It'll just be the code part so that people can look at the code and copy and do their own thing with it. But yeah, I'm still looking into that. So, but the end goal is to make, if I ever get that far, who knows? That's the big question always. I might eventually hit a roadblock and we go like, how do we proceed here? At some point there will be the need to finance it, and that's where a lot of these projects do go wrong. If I'm going to have to hire people who can do the things that I can't do, like model stuff and make music and all that sort of stuff. That's very far down the line still. On the short term, the plan here is to get to a point where we have a simple game that works with a single level, and potentially something like through my Patreons or something like that, I might eventually make beta build or alpha builds available for people to play with and have some fun with. Again, I'm not at that point yet because I need to start looking at exporting the project and making sure that it's a proper executable and all that sort of jazz, and find a place to upload it. That's still something that I'm looking into. I think it's too early in the project to do that sort of stuff. Question, but the car series, could you... okay, so I do have a Discord. Right now it's Patreon only. So if you sign up for my Patreon, you get access to the Discord. But I am contemplating making some of the public channels just available for everybody, and have just a members only section for the people who are actually my patrons. So yeah, still looking into that, what I want to do with there. But I have a Discord, it's just not public at this point in time. As for the car series, I need to get back to that at some point. A lot of the stuff that I'm doing here sort of applies also for the car project. There's a lot of similarities between space and cars as far as how you structure AI, how you do a lot of things in structuring the game. So yeah, I do want to get back to the car tutorials at some point in time. But right now I have too many things already on my plate. So the car tutorial is on hold for the time being. Hi Bailey. All right, cool. Yeah. Oh, yeah. I remember that. I think we talked on IRC about that a bunch of times. So welcome to the stream. Glad that you could make it in. And yeah, at some point, show off what you're building. Always good to see. Okay. Anything else on the chat? All right. Let me just fill my water up. All right, there we go. All right, so when we are looking at our enemy has a shield. Now, for now, I've just made the shield a sphere, just to keep it easy and handy. At some point, I do want to start using a mesh for the shield, but the stuff that we're building will stay the same. It'll just be interesting to see how we will deal at that point in time with the collision shape. Now, one of the problems that we're having is that, especially with our laser bolts travel at a certain speed. As a result of that, we stretch out the collision shape, and at some point in time, the collision shape hits our sphere, and we currently don't know exactly where it hits. Now, that said, there is a question how important it's going to be, because seeing the scale that we're working on, we might hit say exactly on the top here, but our laser bolt, actually the position is somewhere above it, and maybe that distance is so small in relationship to the size of our shield, because this is a pretty big shield. 18 meters in radius, so that is too late, 36 meters in diameter, so that's a pretty sizable shield. And even with our bullet traveling, that's a good point actually. How are we making that move? I think we're just doing, oops, not that, so this one. No, that will then be in the laser beam itself. We are just using the initial velocity, so we're not making our bullet go faster or slower, are we? It's been a while since I last worked on the projectile logic. Yeah, I think that when we look at the laser beam, we're having it travel at a fixed speed. And I guess, no, we don't have any linear damping on, so that travels in a fixed speed. We don't really have any metrics at the moment of how fast our ship is moving and how fast our projectile will be traveling, because that will give us the distance that it travels in one frame, and that's kind of important to see whether that is much bigger than our shield or if it's just a small fraction of our shield. Our logic will work fine. Oh, welcome, Louise. I'm glad you're joining us on the stream. And Bailey, yeah, it's a lot of fun to do these streams. Even if there are only a few people watching, you know, I got a little bit lucky because obviously I've got my existing YouTube channel, I've got my existing videos, so people already know me, and as a result, you know, I'm blessed that at least I've got a 1 or 2 dozen people watching me. A lot of people start streaming and they only have 2 or 3 people watching, but as a motivational thing, it gives you a reason to work on projects every day or every week or whatever schedule you said. So I enjoy streaming, but it's not for everybody. Do keep that in mind. No, not everybody likes having people watch over their shoulder and see them make all your mistakes. I make plenty of those. Okay. So the idea when we're looking at our shield is when we hit our shield, we're going to remember where that projectile has hit our shield, and that's going to be a trigger point for animating our our shield being hit. And that's going to be a time-based thing. So we're going to have some fun with how we're going to do it. The other thing that I want to do is I don't want the shield to be nicely one single color. We've got our little Fresnel effect on there so that it's clearer at the edges than at the center, depending on which direction you're looking from. But that's something that I really want to take out as well. So yeah, there's going to be a couple of fun things to start looking at how we're going to implement that. I think we're actually going to start by giving our shield a bit of an animation effect. I think that's probably a good idea. And then we start looking at our shield being hit by projectiles. Well, Dragio, I am still happy that you try and follow the stream, even though your English doesn't help you much. But yeah, I hope you can follow along enough in what we're doing, and I hope that the other people in the chat will take some time to sometimes translate some things if something is not clear to you. Because obviously I'll be working on this and I won't always have time to keep up with chat, but I'll try my best. All right, so our shield is actually in our main friend or foe because it's something that that every entity has. Now, right now, like I said, it's always a sphere. So the only thing that currently doesn't have a shield is our carrier, because that would just be crazy. But we'll probably play around with other shapes at some point as well, and we'll have to see how that influences our collision detection and our physics engine. But that's a problem for later. I'm not going to worry too much about that right now. So we have a shader material, and on that we have a shield shader. So I do have a separate material here. And that's just to make sure that every instance, every object has its own material. Now I'm going to have to double check to see if we actually do that in code or if we are assuming did we have this set as a, well, we don't have it local to scene, so I'm going to tick that on first. But we might have to do some more with that, because of course once we start animating our shields, we want them to all be independently animated. We don't want every ship to do exactly the same. So if I hit one ship, all the shields react. All right, but that is something that we'll deal with as we get clearer. Now, the other thing that I want to do right now, just to make things a little easier, is that I'm going to turn the alpha down. So I'm mixing that alpha with our Fresnel value. Oh, actually, I'm just using the normal in this case. I'm not even doing a proper Fresnel logic here. That's okay. That works just fine enough for what we're going to do. But I want that to be a little bit clearer so that we can actually see our shield do what we want to do. Now, obviously, I'm going to turn that down again later on, because this is one of the things where if the shield gets too visible, the enemies stand out way too early, and it becomes too easy to actually hunt down your enemy ships. The shield effect should really be much clearer when you get close to it. And maybe at some point we'll do some sort of distance fade, so that the further away from the camera we are, the more translucent the shield is. So it's going to be harder to see from a distance. All right. So the first thing that we're going to do is we're going to overlay a texture on our globe, and for that I want to have a pattern. So we need a new uniform. I actually want my other keyboard, please, because that keyboard is horrible. That's not texture. It's forgot now. Auto completion would be so nice right now. God, what is Write shaders almost every day, and I completely forgot what it is. So, Godot docs shader. Sampler. Sampler 2, no, 2D? No, it's not sampler 2D. Okay, I am going to look that up. Why can't I suddenly not remember what a texture type is called? Just want to say hello and thank you. Hi, Vlad. Hello, how are you? Can't stream because I'm at work. Oh my god! Yeah, be careful with watching these sort of things from work. It might not be the best idea. Although I work from home and I tend to have a stream on in the background, which is always nice to just Some people listen to the radio. I've got streams on in the background. Thanks. I'm glad you enjoy the videos. I hope you guys aren't too upset that I am spending a lot of time. See, it is sampler, but 2D with a capital D. Look at that. I'm spending most of my time on the little space game at the moment. I do want to go back more to the tutorials that I've been doing. I said it last week. Unfortunately, I didn't get time for it this week. This week got a little bit crazy at work. One of my colleagues, unfortunately, ended up in hospital. Not because of the pandemic, other reasons. So I had to take over a bit of work. And as a result, you come home and it's very hard to then still find motivation to do things. But yeah, like I said last week, I do want to add a second stream at some point in time, or a second day to stream, because I want to start doing some experimentation for my tutorial. So my next tutorial that I'm planning is for my object interaction. So I want to start looking at opening doors and opening cupboards, opening drawers, that sort of stuff. And while I've got the basics of that running, I still want to do a lot of improvements in there. And I think it would be nice to just do an experimentation on stream so people can see what the thought process is, and then turn it into a tutorial for people who just want to look at this the solution. That also means that I can take some of the exploration out of the tutorials and purely focus on, this is the solution I came up with, this is how it works, this is how you can do it. So that's something that I'm playing around with doing. So let's see, did I do that correct? I did that correct. So I added a new uniform. So a uniform is a variable in our shader that we can set from outside the shader. So you see that the moment I added this, I now have a new shader parameter. This is the type. So interesting name, sampler 2D. It's, you sample a texture. So this is a sampler that samples a 2D texture. We give the little thing a name, something that we know what it is. And then there's a hint. And the hint is an optional thing. We don't actually have to specify that. But with textures, you want to tell Godot whether this is, and I'm actually wondering about that because I don't think it's actually albedo texture. I think it is, let's see, actually texture hints. I'm actually surprised that it didn't give us a error on that. Full list of hints below. So here we go. So there we go. No, hint albedo. That's the one that I need to do. So hint albedo is basically the hints that you give to the shader to tell it this texture is a color texture, or my primary color texture. But the other options that you have here is that you can say, well, I want a color texture, but I want to make it black. So this is the difference. If you use hint albedo and you do not give it a texture, Godot will treat it like a white texture, just a texture that's all white. And that means that whenever you sample that texture, even if you haven't got its texture set, you just get a white value back. With hint black albedo, you get a black value back. So it's a black texture by default if a texture is not assigned. And that can be very important. Then we have a hint normal. So that's the hint you give it if you want to tell the shader, this is a normal map that I want to give it. Now, we're not dealing with normal maps right now for our shield. It's not important. Well, Bailey, don't worry. Even when I'm doing more tutorials again, I am not going to stop doing this because I'm having way too much fun with this. So it's going to always be in the two different things that I will always be doing on my YouTube channel. So here we have hint white and hint black, which are just other names for hint albedo and hint black albedo. So they work basically the same way. And I don't know about the flow map, actually. That's a new one. I have not worked with that one before, so I am not quite sure what that is. That'll be an interesting one to experiment with at some point. So we want to have a shield texture. Now, one thing that I want to have a look at is we should be able to create a noise texture. It's a new feature in Godot. And I want that to be a seamless texture. And simplex noise. Do we want a simplex noise? Because I actually want a whirly shader texture. Which we don't have. Oops. So that just makes a noise texture. That's not what I'm after. Now I could use my little whirly shader generator that I have, but I think we're going to make it our lives much easier. And we're going to just say whirly texture. And let's see if we can go and get a whirly texture that is free to use. Actually, I should probably have looked for that on textures.com or something like that. All right. Okay, that makes sense. A shader editor for VS Code. Oh, that means if you're not using hi Alan, Jan, how are you? You mean when you're not using Godot as your code editor, but you're using VS Code as a code editor? Yeah, I guess that that could be useful for people who work that way. Yeah, well, I could use my. I haven't actually looked at that for a while. I could just use that, of course. Let's see, where's my GitHub page for that? Here we go. And let's go and clone that, shall we? Seeing I made my own asset for that, why not use it? Developments, my games, space. No, actually, I want to go and put that in my Godot assets. And let's go and grab my own little noise texture assets. There we go. And now we need to copy that into our projects. So, development, assets, noise texture. There we go. Let's just go and copy that. And now we go into space, add-ons, and we just dump it there. There we go. Alrighty. Now the interesting thing here is I really should make a generator out of that. Let's see. I haven't used this for a while. So there's our whirly texture that it generates. So that's just a color rect, which does that. I really want to just save that instead of generating a new one every time. You know, it can't hurt. Yeah, for now we'll just put it in there. Why not? But that's probably something that I am going to improve upon at some point. There we go. So that's our viewport texture, whirly texture, all good. I do want that guy to be bigger. 256. 256. All right, that should be good. Oh. You have to be careful with playing the animation player. All right, so now we should be able to go onto here, and I don't want to do that one. Now I want to do a viewport texture. So, okay. Clear. Oh, because this thing is no, this thing we made there. Why is it complaining about that? Is that a file? Shader is a file, but this is local. Local to scene. I thought I made that local to scene before. Did I make the wrong one, local to scene? Oh. Can I do it now? Now I can do it. There we go. All right, so we have a whirly texture. Now the way that the whirly texture generated that I wrote works. Oh, hold on, let me see. Tuna Fish 117, hello, how are you? Yeah, Godot uses GLSL as far as the shader language, but what you write here is a structure specific to Godot. So I'm not writing the complete shader. If you look at a GLSL shader, there is a lot more code in here. We're only writing small parts of the shader, and we're getting a whole bunch of base logic from Godot itself, and it just injects our changes. And that's why even if we don't have any logic in here for positioning and that sort of thing, or any logic in here for our lighting calculations, because there's no lighting calculation here, they still get applied because we're piggybacking on the base logic that's in Godot. So in that sense, I'm not sure if the syntax highlighter in VS Code will do everything correct for you. But it should do a lot of the auto completion, because all the functions that you see here, like normalize and clamp and texture that we're going to be using in a minute, they are all standard GLSL functions that we're using. Yeah, exactly. When you look at hi Vlad, by the way. When you look at the spatial material that you can use, it does all your PBR stuff. So unless you want to do something out of the ordinary or something extra, then you switch to this. But again, you get the whole basics of the PBR shader for free. You just implement a small part of the logic on top of that you actually want to customize. Yeah, it's all GLSL. So even with Glass 2 and Glass 3, it's GLSL. And even Vulkan, the shaders will remain GLSL. It's just they get compiled to a different intermediate format. And they're within a different structure. So, textures will work differently and stuff like that. But the language you use, still GLSL. All right, so our whirly texture that I wrote, so we can see that's a viewport. If we open up that scene, we actually need to go into that scene that we already saw that before. So basically, all that it does, it renders this quad. I'm not quite sure why that's not properly centered. It should be centered. I'm not quite sure. It looks like a bug to me. Here we go. So let's move that into position. I think it's actually positioned in code, so it shouldn't really matter. But you can see that there's a couple of colors in here, and basically I've used every color channel to create a texture at different octaves. And the reason I want to use a whirly texture is because it gives this nice sort of randomly cell-like pattern, and we can do some funky things with that. Now, what I don't like about what we're doing right now, and why I was hesitating a minute ago, so let's go and save and close that, is that right now we're including that viewport in every one of our ships. So we end up creating a viewport for everyone. We only render our whirly texture out once. We're not rendering it each and every time. So that bit is pretty good. But it is still wasteful. So eventually, and that's something I won't do tonight because don't feel like wasting too much time on that. But eventually I'll add a save option in here that you can actually save this thing to a PNG, and then we just use the PNG. Much easier. Because there's really no point in doing it any other way. So, on our material, we now have our whirly texture. So that now becomes our input. We can start doing things with that. And what I want to do for now, for a base, is I just want to map that over our globe. So we need to figure out what the best way is. Now, let's start with the UV maps that are actually standard on our globe. They might just be fine for what we want to do. And we're basically just going to add that into the alpha. So I actually want to go and take this and make a new variable out of that. So we're going to call that float a. And I guess I could do it directly on the alpha value, but I kind of like doing it this way. And what I want to do right now is I just want to start with saying texture. I don't need to do texture load in this case, I think. And then our shield texture, and then we use a standard UV, and I just want to use the R value. So let's see what we get now. Actually, maybe I'm just going to equalize. I want to see just the effect of our whirly texture, which is not really what I'm expecting. Now that could be because we are running this in the editor. So I'm just going to go and run the game. I'm going to see if it actually looks proper on one of our ships. So I'm not going to wear my headset. It's going to look in the somewhat into the right direction. Now if this is so, then maybe we are going to make the extra time. Yeah, so we can see that the whirly texture is actually being applied here. It's not very clear. Well, I think the problem that we do have is that the effect is too strong. We could see it better when we were looking from this side. Oops. Yeah, why did it look so much better when we were doing it from a distance? It's interesting. Where are my ships? I went too far. I went too far. So here we can see that it has like these patterns on it. But it's not obvious enough. So the big question that I have is our whirly working here? Yeah, I think it is. I think it might be. All right. Let's go back. Yeah, we can see it's actually working. So our viewport is rendering. We're just getting the effect too overpowered. So I want to actually go to one of the other levels. Because what we can see is that on the other colors, we're actually getting... so now we can really see the effect here. On the higher levels, we just have more octaves, and that means that we got more cells. Now, I don't really like how uneven distributed it is, because it's sort of, because we just have a spherical mapping on our globe, so everything at the top gets sort of compressed. I don't think we can really do much about that at this point in time. But we can add a little bit more tiling. Okay, that is something that I wasn't expecting. Oh, it is not. Okay. It is not. I'm not sure if we can do that with a viewport texture. There we go. Oh, it seems to work. So let's see if he remembers that. So now it's tiling. So yeah, I'm not completely happy about the top. We'll need to find out if we can have a different type of UV mapping on a globe. But for now, we'll keep that working like this. Okay. All right, let's have a little bit more fun. Does it make sense to just calculate that here? I think it is. So I'm going to create a new... Why is this actually all... Why is that there? That's supposed to be there. So UV1 vector. So I'm going to create a new variable outside of my my vertex and fragment code of type varying, and basically a varying helps actually if I put that the right way around. A varying variable is a variable that we're going to calculate in our vertex shader, and that is then used in our fragment shader. But every fragment between the points of a triangle, you know, of a polygon being rendered, that value will be interpolated as we render our triangle. Let's see. Yeah, so right now the shield texture is just an image, but it's generated on the fly by some code. So that whirly viewport that I have here, you can play around with these variables, and that means that what is max distance 1? 0.5. That might have something to do with the fact that actually, let me have a look at that, because this is a color. Is that something that purely works on here? It's been so long since I made this. I think so. Oh, once we have this thing working, we'll play around with those settings, because I think we can do a little bit more with it. Where is my shader? Because we broke it first. So anyway, back to explaining what I'm doing here. So varying, like I said, it is a variable where I'm actually going to go and calculate that right now. So we're going to say in our vertex, we're going to take the UV, and the UV itself is a varying value. So we're going to take the UV, which is the UV of our sphere, and we're going to store that into the variable here, which now becomes a new output of our vertex shader and goes into our texture. Now, interestingly enough, it is not happy about what it's doing. And I think it has nothing to do with our UVs. So let's just go and open this again. There we go. So the reason there is because we were just playing around with our viewport, we actually damaged our viewport. And we suddenly had a white texture instead of our viewport texture. All right. So the reason why I am now calculating it in our vertex shader instead of in our fragment shader is overhead. Basically, it's much more efficient to prepare your UVs in your vertex shader and then just have them interpolate on your fragment shader, because we're going to do more things with it. So I actually want to turn this into a new vec, and we're going to break it into 2 parts and do the same calculation, because now we can have some fun with it. So let's just add time to it and see what happens. All right, so our texture is now spinning. Sweet. All right. Hi, Satan. How you going? Yeah, you know, I'm just using what I have available right now. But you are right. If we turn this into something that is actually I can't even pronounce that word. Euclid rect coordinates conversion. Then we could definitely use that, and that would solve the fact that at the top it's right now it's you know, it's on like that. So I actually want to go and put in a factor here for our time. So that's going to be a fact2, and that is going to be UV1 speed, and we're going to default that to let's see, because that's going to be a scale. I'm going to do that with a scale as well probably, but let's just do that 0.5, 0.2, just see how that works. So in this case, we're going to take the X, make it rotate a bit slower. So time just increases as time goes by. There we go. All right, so that now rotates one way, but we're going to get a second one. I'm going to make that go even smaller, but actually I want that one to go in the opposite direction. Then we're going to make a varying vec2 UV2. So we're going to have a second coordinate that we're going to use. And we're going to go and calculate that one as well. I think we're going to keep the same scale. Yep. All right. What I want to do now, so we're obviously going to be using our other logic in a minute as well. But we're going to do this 2, and we're going to use G here. So that's going to be at a different. Okay, so that does get very overpowered because we get 2 values. And actually, I want to make that. Like this. And we're going to multiply that one by 0.5 because, of course, now if you add both values together, we go to 2. But we want a value between 0 and 1. So now what we can see is that we actually have the mix of 2 of them. And you can, if you look closely, because they are, the big one is a bit overpowering. So I am actually thinking what we're going to do, let's make this times 0.3. Yeah, now we're going to get 2 things that are nicely moving together. Cool. And now I want to multiply that with our normal that we currently have, which is way, way, way too dark. Okay, that is not such a good idea. So we do want to add that in. We might then want to make it less overpowered. Oh, don't do that. I think it disappears a bit too much right now. Maybe keep that at 3. I think once we zoom out too far, you really don't see the effect anymore. It's really once we're close to it. Now, the other thing that I'm not really happy about is that I want it to be sharper. I want the blacks to be blacker, and I want the shield effect to be sharper. So the way that we're going to do that is that we are going to overpower this. Right. Let's clamp this guy as well, by the way. So clamping, you make sure that the value becomes between these 2, so it never goes over 1. And I think I want one to have this one in a separate calculation. Alright, so I'm just going to call that guy whirly, because then we can do a little bit more with our whirly value. Alright, now the other thing that I want to do, I keep clicking on the animation, that's not what I had in mind. I want to make sure that that one, no, that's just a distance to between points, I think. No, I'm pretty sure that the whirly itself goes between 0 and 1, so that's fine. All right. So we now know, because we're multiplying that value is 0.3 and that value is 0.2, we now know that we're going to get a value between 0 and 0.5. And I think we're going to actually do that in the end here. So I actually want to go and take this back to becoming all the way to 1. Oops, 6 to 1. All right. I think what we're now going to do, so now we know that we've got a whirly value between 0 and 1. So I'm going to multiply this by 2, and I'm going to take away 1. So now I get a value between -1 and 1, but I want to go and clamp that. Oops. Between 0 and 1. So this means that basically all the values that are below 0.5 will drop off, they will be black, and we're purely ramping 0.5 to 1 as our values. And I think that now it is very clear that our animation is way too fast. So we're going to actually slow this down a whole bunch. There we go. And I actually... yeah, that's actually kind of cool. All right. Let's see. I'm gonna try Thetan's idea. And the way we simply do that is we're gonna ignore what we're doing here. So you're saying do this. And then minus that one. ORG. Yeah. And that needs to be V2. There we go. What does that do? It doesn't like fn as a function. What is the fn supposed to be? Is it a GLSL function or is that a yeah, emission isn't going to do a whole lot here, although I think that might be something that we actually want here. What's fn supposed to be? Don't know. I don't know that function. So, Thetan? Oh. Okay, what did you mean, Thetan? Did you throw me on the loop there? All right. So we're gonna go start with that. Yeah, there is a good. Oops. I'll actually move this down. Oops, not too far down. Down here. I want to go and uncomment that. All right, see what that does. I just want to see. Whoa! There are two emission values, I remember. I think. Yeah, that's right. That's why. Albedo is already white, so I just want to make alpha go to 0. Okay, that's weird. So is the alpha also being applied to the emission? That's a good question. So let's make the albedo black. No, let's get a black one like that. Because that was the problem that I was having with the displays. Where are my player scenes? Here we go. Plane. Interceptor. Let's have a look. Yeah, you're gonna be all right. Hang on for a sec. Materials. So one of these guys. How have I got this set up? That's all fine. Mix. So albedo is black on this guy. So actually, oh, where's my shape mesh? Because these are using the emission. There's an emission operator there. So build save. I always fight with emission maps for some reason. Oops. No, I need to get shit. There we go. So, is there another value in the emission that we need to set? Is that a render mode? It could be render mode. Well, that's blend add, it's not emission add. Well, one thing that we could do yeah, I don't think the emission add does anything extra. That's the thing. See, that's not going to make much of a difference. It is a bit of a problem that right now our shield does get, you know, affected by light hitting it. And that obviously will be nice with the emission. No, let's just put the emission in like this. You know what? I'm just going to go like this. And we'll see. I'll fine tune that some more later on. Okay, that's a look. Amanda's stand-in for the time. Oh, okay. Yeah, no, that's one of the things that I don't like about YouTube. YouTube does have a big delay between you guys writing something and you hearing my response. Doesn't always help. Anyway, I'm not quite sure yet if I'm going to leave the emission logic in. I'm just actually going to leave that out for now. So my whole idea here was to get that whirly effect. However, I did actually want to go and make it a multiply by whirling, which means that it's now only at the edges. We actually don't see the effect on the shield itself. Now we need to have a think about what is our base here. Because I lowered that to kind of get rid of the shine on the sides. But now because we're only highlighting the ring, we just get a very faint effect on the outside, which is exactly what I'm after. Because now we're going to do something with when we hit, and we're actually going to override this logic or this with when something gets hit, so that we actually see that whirly effect in like a shield dissipation. Now the trick with that is going to be that we're going to need to, and we're going to do it just for one hit point at the moment, but eventually I want to add a number in there so that we can sort of cycle them through. So that means that we need to, I don't think you can actually parse arrays in Godot at this point in time. So so let's say that we have a maximum of 5 hit points that we support. We're going to have to hard code those in and then cycle through them in code. So hit point 1, and I want that to be way off for now, because that obviously is going to be a location. Actually, you know what? No, we're going to make that 0, 0, 0. We're just going to check whether it is non-zero, because we're never going to have a hit point on the center of our globe. The second thing that we want to do is a float called hit time, and we're going to set that to our time variable, so this guy, because we have that available in Godot as well, when we actually hit our sphere. Okay. Now we're going to start with doing this without actually animating this thing. So I'm going to ignore my hit time for now. I'm just going to use my hit point. And what I want to do is go and figure out what the distance between my the current fragment that we're currently rendering and our hit point is. And again, we can use that. We can do that on the vertex shader and then interpolate those values, and that will be accurate enough for what it is that we're doing. So we're going to have a varying float hit distance 1. There we go. Why is it unhappy? Because I'm not allowed to have a value set there. We need to calculate that. We're also going to calculate what our vertex position is. That should not be normalized. I'm going to copy that through. But now that one's a 1, so that's how we are going to calculate. That should not be a model view matrix. That needs to be, I think that's our world matrix. Yeah, because we want to know. That's a good one, actually. No, we're not going to do that like that. We're actually going to make sure that our hit point 1 is in that one is in local space. So all we're going to do is calculate our hit distance 1 as our vertex, take away hit point 1. There we go. Now the other thing that I think we want to do here, why is float and hey, yep, and we want to obviously get the length of that. There we go. All right. Let's see, how's it going here? Yeah, I'm thinking about using render mode unshaded for this. Oh, it's actually already on. Oh, that's why. Yeah, that's why the emission doesn't work. But that's also why this effect is actually exactly already what I want. Remember, we're using the class 2 renderer, not the class 3 renderer. So we're not actually emitting any light. We're not causing this light to light up other objects. So all that the emission would do if this was a lighted object, if this was an unshaded object, is basically exactly the same as what we're doing here. That was why that was working the way that it is. Because if this wasn't unshaded, our you can see that almost everything disappears because we don't really have a light in the scene. We just have our ambient lighting, so the whole thing disappears. Of course, in our main game, it would only be lit from the sun side. But I don't want the shield to be lit up anyway because the shield emits so much. But we're just not using the emitting for that. We're just not shading the thing. All right. Who's opening the door? I don't know. Okay. What else is being said here? All right, so when we look at the shield texture that we're using, so the whirly texture, there's just I've actually got a video on that, which is well, actually, if you look at whirly texture, just Google it. Whirly noise is a good Wikipedia article about how it works, but it's basically you random generate a bunch of points and then you calculate the distance between the points, and then the closest point determines, you know, the shading of your texture. And I'm using that right now as something that I generate, but more ideal is just saving it as a PNG and just using it as a PNG. Why Van37? Welcome from French. Nice that you can join us. IK Android. Bailey, come to Australia. We got good coffee here. We love our coffee in Australia. And yes, there aren't enough shader tutorials. I know that GD Quest is working on a few, so they're doing some really cool shaders right now, and they've got a whole shader pack you can download with all sorts of cool effects. So definitely worth checking out. Hi, Sketchware. Sound is low. Sorry, maybe. Let's see if that works. Let me know if that's better. I hope that didn't make a whole bunch of noise. Putting that closer. I have my microphone quite a bit away. So I hope that's better. Sorry about that. Yeah, Voronoi and Whirly are siblings. They work on the same premise. It's just the Voronoi ones have got slightly harder edges. Not quite sure what the difference is. I remember when I researched this and I wrote the code for the Whirly. There was just some slight calculation differences between the two. Anyway, the thing that I wanted to do here is if hit points 1. Then we're going to calculate that. Else. Oh yeah, that's right. This is C based. So use our curly brackets and everything. There we go. And in this case, I just want to hit distance. Actually, I want that to be very big because that's the only way that we're going to make sure that it doesn't apply anything. And this is GSSL, so floating point values have to be with a decimal point. Okay, so if we have a hit point set, we are going to calculate our hit distance, else we're just going to set it to a really big number. Why is there a tab behind there? I don't like that. So now we're going to do a calculation with it. Now, I actually want to make sure so that we can play around with this. The default size of this thing was 18, wasn't it? 10. Okay, then we're going to use 10. So we're actually going to be putting that on 10 on one of the axes. That should now, and I'm going to put it back to 0 to 0 in a minute. But for now, that will allow us to see what we are doing. All right. So when we render the fragment that is exactly at that point, then our length calculation here will be 0. And the further away we go, the higher that value will be. So we actually want to flip that upside down. So we're just going to call that hit 1. And do we do that 1? Yeah, why not? Distance 1. There we go. And for now, I'm just going to clamp that between 0 and 1. So now we should get something that for 1 meter size will slowly go from white to black, and then it will stay black, or from 1 to 0, and it will stay that way. And I just want to go and add that into here. And in this case, I'm not caring that we might go over that value. So somewhere on our globe, you should see something. Now, I don't know if that is because... Let me just see if we just have a value that's too small. or if we're doing something wrong somewhere else. Okay. So that's interesting. Do we do this with a scale, or do we are scaling it? That is why. Okay, that makes sense. So our local coordinates are that's actually a good one. Yeah, the radius of our sphere is 1, not 10. We're scaling it up by 10, but the radius of a sphere is 1. So everything is being done in that coordinate set. And eventually we're going to be using the global transform of this to transform our hit point into local space. So we're going to be using that value 1, which actually makes our code a lot easier. It also means that if we have a bigger shield, the effect will be amplified, which is going to be interesting. So that means we're going to go back to 1. We're going to go back to 1. But we're now going to put our hit point at 1. So, does that make a difference? Still doesn't. All right. I'm actually going to turn our whirly off for a sec because I want to see if we can see more clearly. Oh, we're still doing something wrong. All right. I actually want to go and just add hit distance. All right. So those values are way too big. Why? What am I doing wrong in my logic? Let's have a look at the chat. Hi Vinny, nice of you to join us from Brazil. Is it possible to make a text shader in 3D, like showing floating hit points? You mean that we can see damage hit points whenever you hit something and you see the damage floating away? Have a look at my physics tutorials. Something I actually do in part 3 of there. When you hit the stones, I make little text thingies float up and away just to show how much damage you're doing. We might do something like that here at some point as well. I first want to figure out what I'm doing wrong over here. Okay, so our hit point is now at distance 1. Our sphere is at radius 1. So why am I not seeing what I'm hoping to see? That is weird. I am missing something here. So, oh, really? Okay, that would make a difference. Oops. Okay, so now we can see that we've hit our target over here, exactly on that sphere, and that's where it's now full value, and then over a distance of 1, which is almost halfway around our sphere, we slowly see it dissipate. All right, perfect. Okay, now the thing that I now want to do, but we can't actually simulate here until we write some code that works for that, is that we're using our hit time. So basically, what we're going to be doing, am I going to add that into the hit distance? Probably am. I think that's probably a good idea. So what we want to do here is create a variable where we're saying, well, our time is currently this, and we're going to take away our hit time. And this is now going to be a value that increases as time passes. Now, this time value is in seconds, I believe. So it will hit 1 when 1 second has passed, 2 seconds, etc. So we're probably going to have to add a modifier here to speed it up or slow it down. We'll need to figure that out. But we can't demo this right now because time right now is a very big number. It increases since the start of Godot. It starts at 0 when Godot starts. It keeps on increasing and increasing and increasing. And we don't know what it is right now. We don't have a way to trigger that. We can only do that in code. And actually, maybe that's what we should do. Maybe we should actually trigger it. That's still something that I really would like to. Let's just make that something over here and say, just for testing, we're gonna make a new export variable, and we say test trigger is false. Set get set test trigger, and then we can write a function for that. Oh, we're not in C anymore. Now, I'm actually not going to assign this. We're going to keep test trigger false. What we're simply going to do is, if that is true, this thing is a tool script. Yes, it is a tool script. Cool. And we have a shield mesh. Then what we're going to do is we're going to go to our shield mesh. And are we using our overwritten material? Yes, we are. Okay, cool. Cool. So that is get surface material 0. So that gets our material. And then we say set shader param, hit time. And now we need to figure out, how do we get time? That's a good question. Where is that coming from again? Is it that one? No, that's current time. That's not what we're after. Time process. No, that's our performance measuring. Hi, Coconut. I'm not know about Godot God, but thanks anyway. We try to do something nice here. But right now I'm trying to find out, how do we get the time passed? That's time scale. That's not what I'm after. Because we're supposed to be able to actually get that value from somewhere. All right. Godot get time since start of engine. All right. I think it is in. Yeah, I could do mod time 5, but I actually want to actually get the value in there that we're using to really see the effect sort of working, so that we can actually test that we're doing the right thing. So these are all system times. That's not what I'm after. There's too many functions in OS. All right, hang on. Okay, so get takes milliseconds. That's probably the one that we want to have. Let's try, see if that works. So that's going to be os get, what was it? Get ticks. Milliseconds, and obviously we want to scale that down because we want it in seconds. Okay, let's see if that actually does a thing. Obviously we haven't done anything in our shader yet, so we can't test it just yet. Let's just go and add that in. Oops. Pause this. There you go. Just add it in as is. So now in theory, if we've done the right thing, okay, that's interesting. It goes all the way once. All right, so now the question is, maybe we actually, that time value is actually already in milliseconds. I don't know. I don't think so. Let's see, shading, time. Let's see the help here in time. Elapsed total time in seconds. So no, it should be time in seconds. The big question is this then indeed lining up with it? Let's see what it actually assigned to this, because it's a really big number, but that's all right. That's what I'm expecting it to be. Or is our whirly texture destroyed again? That's possible too. Just in case. No. Okay. Just trying to find out where about we are. And closer. Okay. Okay, so we can see that we're around this point in time right now. Oh, we're already past it. Okay. It almost seems to me that time is actually expressed as how much time has passed since this shader was loaded. See if we can quickly find out what it is. I can use that one, that's good enough. Where would you find that? Is it in the drivers? It might be in the drivers. Frame time. Okay, have we have access to that? I don't know. Find out. Should be in our render logic. It's a frame number. That's the number of frames rendered. That's not what we want. If anybody here has any ideas. Yeah, no, the docks are very, very handy. Now you can't have everything in your head. Sometimes you just have to find stuff. A trick to debug values in shaders. Not really, to be honest. There are shader debugging tools, but I have to say that I don't have enough experience with them. So this is indeed since process started. That will be interesting. I'm going to try that one. I'm going to see if that works for what we're doing. Because that would kind of match with the fact that we are doing, we're getting a frame time value. So let us see if we can make that work. Time passed. Float is 0. Oops. Keep mixing up what we're working in. All right, so the bracket here. So now we need to make sure that time pass gets increased. Have we already got a process function here? No, we do not. So here we just do func process plus is delta. All right. So that does mean that we need to go and reopen this. Now let's see if that works. I don't think they're right about that. So let's see if it's still around that value here. So oh, I'm gonna need to go the other way. Okay. Okay, so that looks like it's still been increasing. since we started. So I'm starting to wonder if it is indeed that modulus 3600, which is really what he's doing. So it might be that our value just cycles through every hour, which would be very unfortunate, because if you're playing for an hour and you shoot the target right before we cycle through, we're suddenly going to be at the wrong end of this value. But that's something that we can deal with. So let's get rid of this, because that obviously doesn't work. Okay. Then we're just going to go and say over here, time passed. And I'm going to go and assume that this cycles every hour. There we go. All right. I think that's fmod. Fmod. All right. What is the value that we're getting right now? So that's 2400. So that's not it either. I am starting to really get confused about this. Of how time is calculated. What is that actually being calculated as? So we really need to have access to that frame time. So that's a big question. Is that frame time available somewhere? That has nothing to do with time. Hi, Soundsbeard. Life is good. I hope you're doing well too. Hi, Sarah Dev. Well, yeah, shaders are a bit of a strange art form, but hopefully I'm making some sense. Although at moments like this, where I'm trying to figure out where we're going to get a value from, yeah, we do get a bit confused. So this does say time since shader started. Hi Scanner, how are you going? All right. So. Well, there is one other option. And that is that we do this ourselves. But I'm really wondering if that doesn't get very ugly. Well, we could do it that way. Okay. Just reset it here. Not sure if I like this as a solution, but it's what it is. Okay. Actually, let's give that a proper name. And we might actually there you go. That's not going to be hit time 1. You want to cast that to that, and we're going to say hit time 1 plus this delta. So we're just going to go and increase our hit time and send it to our material. And when we trigger our hit, we're going to set it back to 0. I don't like this as a solution because once I'm planning to do up to 5 hit points, but that means that for every shield we have in the game, we're going to be updating 5 values every frame in our shader. It'll do for now. We might eventually change this over to once I figure out how to get the value of time as it is present in the shader. We'll change it back to the way that I was just trying to do it. But for now, we'll just do that. Now, of course, right now it's to set test trigger, but that obviously is going to be removed. I'm actually going to make sure that that is over there. So this is not CBAS, just a test. Obviously, we're going to change that to, when we get hit. So it's going to be in our take damage. We're actually going to start sending that a location. Where did we get hit? And we're going to set that and set our hit time. And that's where we're going. And actually, our scale of 10 is going to help us because even if our hit point is slightly off because of the size of our collision shape, that's still going to work itself out, I think. So I think that's going to be the workaround for now, which means that now in our code here, we can just add in our hit time, and we don't need to do that. There we go. And now, in theory, if we've done everything right, there we go. All right. All right. So okay, now I don't want it to be like this big blob that just sizes down. I actually want it to be a ripple that goes outwards. So that's our second, or our next step that we're going to be doing here. And for that, I actually want to go and subtract hit time, and that's going to probably screw up our thing right now because of the way that we're doing this. Because now we're going to have to change this calculation here. So when we hit, I'm actually going to go and take that out for a minute as well, because I want to go back to seeing what we saw before so that we can do an explanation. So when we hit, and our hit point is over here, that's right now our test hit point. Then at time 0, when no time has passed, that is value, that is a distance of 0, and it goes around, and our distance increases the further around the globe we go. Now, as our time increases, we are right now decreasing our distance. So at time 0, the point over here will move closer. Is that actually what we want for our effect? Let me think. Because what we want is for this to become a ring that actually slowly expands outwards. All right. Let's try something. So I actually want that to be 0.12, and I'm going to divide that by 0.2. But now I want the absolute value of that. Okay. All right, that's not working. Because now it does go. Okay. I'm thinking the wrong way here for some reason. No, I'm thinking about this the wrong way around. That's why. Okay, sorry about that. I have to get my thoughts in order before we get this the way that I want it. So what I actually want to do is hit distance. I want to divide that by a value. Is that it? What do we get now? Okay. Oops. Getting there. So we are at now. Sorry guys, I'm just trying to think this through. Oh, I am still subtracting the time, so that's indeed going the right way around. So at some point, this is going to go. Okay, so actually, let's just make it absolute. Let's see what happens when we do that. Now that's going to go the wrong way. Okay. Well, surprising, that was exactly what I was after. Now the other thing that I actually think is this thing probably needs to become two-sided. Let's have a look. Let us have a look. Go disabled. That always works really badly with a. Okay, and that is because now we've got that guy. No, that doesn't work either. Actually, yeah. That's what I wanted. Yeah, there we go. Okay, that's interesting. Why do I get a halo like that then? It's funky. Interesting. We do not see it go all the way around. But it's too strong. Okay. Interesting. Oh, because we've got 2 layers now, we probably want to make that go only halfway, because we got double things overlapping. Let's add our whirly in. Let's just see how that looks. That's pretty freaky. Okay. And now when we hit it, it's kind of cool. I'm wondering if... Okay, so the fact that we are now not doing back face removal, which means that we're rendering both the back and the front of our globe. It's going to be interesting to see if we actually have a ship in between. There we go. It kind of looks cool, to be honest. What I find interesting Oh, this one actually doesn't reset properly. Okay. Don't say. So it goes all the way around. I wonder if it should completely disappear on the whirly. I'm actually going to clamp that a bit more like this. I'm going to add that in, just to make sure that we always have at least a base. Okay. I think for now that will do for what it is that we're trying to accomplish here. Okay. Hi, Christopher. You're more than welcome to lurk. Hopefully you are learning something from this. So yeah, we can see the effect a little bit more clearly if we don't take the whirly in. Although I am surprised by how the overlap is now that we've got the back face removal turned off. But that's because I wanted to see the back of it as well, so that we really see our shield impact go all the way around our object, which is cooler than that it just is, because of course, you know, the shield is see-through, so you should see the back effect of the shield as well. But it does give a bit of that effect of, you know, that it sort of looks a little bit dull. It looks like there's like a second ring inside. I'm not quite sure if that's just an illusion or if that is something wrong in the way that I am calculating that outer shade. I'm not sure. But with the whirly effect added in, which gives us, you know, the idea that our shields aren't a solid thing, but sort of like an energy field, which is kind of cool. Yeah, I think that that does it well enough. And again, we might even actually probably will tone this down a little bit more. There we go, just to have the base color toned down. So you don't want the shield too visible when nothing's happening. But then when we hit it, we're gonna get that effect. Now I think that effect isn't going fast enough. I really should have that shader on somewhere. And I also really hope that I'm not using that shader in other places. I think it's only here. So yeah, I want to make sure that our time here gets scaled a bit faster. So yeah, so boom. All right. Okay. That now means that we do want our default hit point to be back at 0. So we don't have one at the moment. And let's just go and add in a couple more so that we can have a couple working at the same time. There we go. Okay, there we are. What are we doing here? That means that we need 5 of these. Whoops. Not quite sure how I managed to do that. There we go. 2, 3, 4, 5. There we go. No. Now, interestingly enough, is that ifs are better than loops in shaders, I've heard. But pretty it isn't. I do need to find a nicer way to actually deal with this. And one of the ways that that is definitely an option for something like this is that we actually encode this into a texture. And then every time, but then we do have to have the time work differently instead of copying 5 times into our shaders. That's what we do for now, but once we solve the, either we're going to have a single time that we use and we're just going to put a start time in there. I don't know yet. That's something that I need to work out. But if that's the case, then we could actually encode this into a small texture that just has the position and time encoded in a color, and then we could communicate that to our shader, and that would be a much more efficient way to communicate this data. But it also would be a way that we could actually handle much more hit points without it actually causing a whole bunch of performance issues. But for now, this will do. I just want to simplify this so that we can copy it more easily. 2, 3, 4, 5. 2, 3, 4, 5. And we're just going to add these all together. And it does mean that if we have overlapping shots, then obviously that will overpower it, but that's why we have the clamp in there. Alrighty. So now we can support up to 5 hit points. Cool. Let's go back to our script here. So I think we're going to keep our test trigger in here for now. This can actually become an array. Can I define an array like this? I'm not sure actually. Probably needs to be a collection, doesn't it? Don't know if Godot supports that. We'll see. Does that work? then that just becomes an array. And we're just going to initialize that when we get the chance. That's going to become array 0. Boom. There we go. And you're going to be array 0. Because, of course, you know, arrays are 0 indexed. But that means that now in our ready function, for range 5, hit time pushback 0. There we go. That initializes our thingy. Okay. Let's do that here as well. E and range, we're going to update them all, but we're just going to go and copy these. Again, a little bit wasteful, but it is what it is. All right. Alrighty. Now that means that we're going to remove our test trigger, and we're now going to work on a take damage. All right. Here. I'm not quite sure about that name. Gonna make that hit where. Okay. Var points 0. There we go. All right. All right. And Sculpt, this calls for a new function. Yes, we are going to add a new function in. I do not use Unity. I got into Godot because I wanted to write my own VR solution. So, you know, before that, I was just writing my own engines. I might try Unity at some point in time. I have helped a few people solve some problems in Unity, so you know, I've seen a bit of how it works, but it hasn't interested me so far. Maybe someday. Yeah, so varying is a variable inside of the shader that is output by your vertex shader and then is an input for your fragment shader. And the GPU will interpolate the values that you output from the vertex shader for every fragment that lies, within your triangle that you render. So yeah, that's what it does. Hi, Kapoor. I'm glad that you find my tutorials helpful so far. That's really good news. Always nice to hear someone can use what I show and find some useful. All right. So if we hit our shield, so if we break our shield, we're going to do something else. That's something that we still need to build. But now, if we hit our shield, we want to go and add this in. Now, that does mean that we need to start looking at where our take damage is being called for. But okay, what we're going to be doing here, that actually is a good reason to, I want to go and, actually let's go and move this whole thing. Oops. I'm going to go and move that into my ready function. So that's going to be our shield material, but that's now not going to be a var. Well, let's copy that because I need to put that somewhere else. And instead, we're just going to assign this. There we go. And now we're going to make that something that we remember because we're going to access it in multiple places. All right. So shield material dot sets shader param. Whoops. I really need to go and put my, where did I put it? Yes. Here we go. That makes it a bit easier to switch between these two. So hit point underscore. Maybe you should have had the hit point start from 0 as well. I don't know. Hits. Did I call that hit point? Zoom in again. I just don't have enough space on my... I've zoomed in the font size quite a bit, which makes it easier for you guys to see what I'm doing. It makes it a bit more filled for what I'm doing. Anyway, hit where? Oh, I need to adjust this. So we're gonna call that hit point. No, because this is gonna be called hit index. I think that's a better name for it. Hit index. There we go. There we go. So what we're gonna do here is we're gonna take our global transform and we're gonna do it inverse of hits where, and of course that needs to go and be assigned to that. So that transforms our hit where into local space for our shield. And actually that needs to be the global transform of our shield. Mesh, there we go. Very important that we use a shield mesh because that also has our scale in it. And that's kind of important here. So we set our hit param there. Then we set our hit time, hit index to 0. Then we're going to increase our hit index. 5. Okay, hold on. Is that the notation in Godot? Yes, it is. Woo. So percentage sign is a integer modulus. So this is going to make sure that when we increase our hit index, so it becomes 0, 1, 2, 3, and then when it hits 5, it returns back to 0. So we're going to go and cycle through 1 to 5, and that way, you know, we can support up to 5. Yeah, well, hits, I guess. All right. So now we have to make sure that our take damage actually sends us our where. Okay. So that, I guess, is always coming from projectiles, isn't it? Take damage. So here we're going to go and cheat a little bit. Weren't we already tracking that? I guess not. And we're just going to give the location of our projectile. And like I said, when this is our laser beam, we're actually going to be some distance away from our shield, but I think that distance will be small enough for our effect to still be pretty convincing. So let's go and hit some shields. And I think this time I am going to wear my headset. Let's see if this works. Is this tracking? Why is my headset not tracking? Now my headset's tracking. Okay. All right. Let's go and shoot something and see if this works. Now, I'm not actually going to go to my enemies. I'm going to be mean, and I'm going to shoot my friends. And why am I going to shoot my friends? Oops, that was not what I had in mind. My finger was on my rocket button. The reason I want to shoot my friends is because they don't move. So we can go nice and close and see what happens. Absolutely nothing. Okay. So. All right. So we're obviously not doing something right. Oh, look at that. Invalid operands with vector 3 in friend or foe. All right. It's not happy about something we've done in friend or foe. So let's go and close that so that stops spamming us. And let's reopen that and see what it's talking about. The 3 and nil operand. 156. What's it talking about? 156. Okay, that's interesting. It has somehow lost our global transform. I'm not sure why. Godot arrays have a 0 index, don't they? Or does that mean that we're actually, hold on, process. Three, 4, yeah. Ready, push back. What are we doing wrong here? We're on time, oh, the 11 o'clock. Why is that giving me problems? Yeah, so like I said, so for instance, the easiest one, let's look at the first one, varying vec3 normal. So I calculated in my vertex. So that's where I do the calculation. It now becomes an output of my vertex shader. And then I can use that value in my fragment shader, which I'll do over here. The same for all the other variants. And what the GPU does is when you look at a triangle that we're rendering, that's 3 points, 3 vertexes. And we're going to render every vertex or every fragment in between. So there's like a couple of hundred fragments that are being rendered for every pixel. And what it's doing is the output, the 3 outputs for the 3 vertices of my normal or my hit distance or whichever varying variable that I have, it's going to interpolate those values over those 3 points. So if my value is 0 here and 1 over here, when I'm halfway, my fragment shader will get a value of 0.5. And it just interpolates between those 3 points. And it does that with vectors, it does that with floats, it does that with anything that you can think of. It obviously can't do textures, but it can do a texture color value. So once you read the texture in your vertex, you could interpolate that color value. So that's what that does. But now I need to figure out, what did I do wrong here? Did I do something wrong in the way that we are introducing this? I think probably the easiest thing to do right now is just to check one frame. Now, interestingly enough, we are getting this continuously. Okay, that was in physics process. Okay. Oh. I didn't think, no, we don't call that yet. One, 4, 6. Still running. Yeah, I thought I was something. I guess not. There we go. Okay. I'm not quite sure what's going on here, but it's really, really weird. Actually, no, let's keep that all disabled. Let's go and do that. Actually, no, I do want those variables. We're just not going to do anything with them right now. I'm going to leave that. So we've got a shield material. And we get our pushbacks here. Let's take these out. Because the weird thing is, oops, It is actually running that code over here. Or that looks like it's getting the errors on that. Well, it's happy now. Okay, I don't get it. It's still happy. Okay, maybe we're not getting our shield material. It's still happy. Go figure. Go hit our breakpoint. Here we go. Divide by 0 operator. What? That has nothing to do with what we're just doing right now. So, why did that suddenly happen? Okay. Not quite sure. Maybe because I context switched just before it got there. I think we need to make a protection there that if our application is minimized, it might be getting a 0 value. So, we're coming here. And we're fine. We've got an array of... I have no idea why that's not 0. Oh, because we've been increasing it. Okay. Yeah, that's right. We've been increasing our delta. So that makes sense. And now we are setting it to our shader param. So our shield material is set. So that's good too. So I don't get it. All right. So now it only communicates the first one, which is fine. That means that our first hit should work, in theory. Unless we screwed it up yet, but I don't get why it was misbehaving and it's not now. Let's go have a look. I'm actually not going to put my headset on just yet. Just gonna... Ah, I hit my hit my missile again. I always keep putting my finger button on the missile. I think my friends are not happy with me shooting the missiles all the time. Okay, nothing's happening still. Yeah, that's spam from my missile. I still need to check why it's repeating that. But we're not getting any errors. We're also not getting any effects. So that is interesting. All right. Okay. Let's go print that out and see if that's a value that actually makes sense, because it can still be that we're not getting a value that that we can actually use. But that should be setting our hit point on our shader material. All right. Okay, let's also see if we maybe have something wrong in our shader. Maybe we forgot to define some of these things. Where are you? Here. So we got our 5 hit distances. We have our 5 hit times. I'm wondering if I should not just put them nicely together. It's a bit easier to read that way. Whoops. There we go. So we can see we have our 5 hit points. We have our 5 hit times. All good. Okay, so it's happy with that now. Let's see now that I've got those all enabled again, whether our problem comes back that we were having. I don't get it. So disabling all the code and re-enabling it all of a sudden mysteriously fixed our error spam in our log. Beats me why that is. I'm not complaining. I'm glad that works. But we still don't have any effects here. Now we do get a bunch of hit points, which make absolutely no sense. That is why it's not working, because those values are nowhere near what I'm expecting them to be. So, what are we doing wrong here? Oops, that wasn't what I had in mind. Oh, I need to get my scene back up. Are we now going to get almost our spam again? No, that's all still working. Okay, so we got a shield mesh here. And that might actually be why that was spamming, because it's a tool. And if the ready function isn't properly run in our tool script, our array won't be set up, or we've lost our array by now. And that's why we're getting those spammy errors. I think that's probably where we're going to go, where we were going wrong. So might need to add a protection for that. We'll see. Anyway, so we're getting our shield mesh using our global position, and we're using our hitware here. Okay. Projectile body entered, has method take damage, and we damage. Do we do something different in our laser beam? No. So we're using our projectile as is in our laser beam. And we're getting our global transform of our projectile, and we're getting our origin point. What are we doing wrong there to get such weird numbers? Okay, so let's log a little bit more info and see if that tells us something. So we want to do shield at, start with that, shield mesh, global transform. I want to see where our shield mesh is, because that won't tell us about the rotation, but that will tell us how close we are to hitting it. Projectile X, and that becomes our hit where. Okay, and then our hit point is the hit point that we calculated by doing our inverse transform, which should transform our hit where into local space. But it didn't. So here we have our error spam again. And I think that is all to do. Let's go have a look over here. If hit time dot size is not equal 5. Let's just put that little protection in there. I think that's where that is all about. So let's go and close that off again. Go into our output, let's clear our output. Go and put it back in. Oh. It's not happy. Is it not? Is that a function? Is that what it's complaining about? Probably is. Let's retry that. Seems to be happy now. Okay, so I think the problem there is because we're doing edits in our script. When we save it, it's sort of reloading the script, but it's not re-executing our ready function, and we start losing stuff. And that actually also means that I actually want to have this there just to be safe. There we go. Okay, boom. 165, which goes back to here. And I think it's got everything to do with the fact that this thing is, whenever I save, it goes wrong. I think that goes everything to do with the fact that it's reloading our scene. It's happy now. So I'm not going to worry too much about that. We're going to see what happens when we shoot our targets. Okay. Now this is interesting. Why am I getting multiple hits? Oh, because we have 2 lasers. So yeah, 4 hits in total. All right, so our shield is there. Our projectile is there, so they're very close to each other. But then our hit at does not make any sense. I'm starting to wonder if our inverse X form has got problems with our with the fact that we're scaling. I wonder if we've just run into a bug. Shield material. No, does not need to be an unready var, because it's basically an unready var is a shortcut for just putting a line like this in ready. So unready var and this does exactly the same. The reason I'm not putting this in an unready var is I don't like more complex functions to be run that way. I trust it more when it's written out like this. I think it's also more clear what we're doing here. But I think we could just move that in to an unready var. I think the problem that we're having is every time that we save this, it is it's basically clearing a whole bunch of the states of this thing. It's not repurposing that properly. But our problem here now is that our hit point isn't being transformed correctly, which is really annoying. So either our X form inverse doesn't work. I'm really starting to wonder if our inverse X form fails when we have a scaled transform. So I'm guessing that we might need to make our own version of this. Okay. All right. Just to humor me, that means I can change this to shield transform as well. Nope. So we can print those. Okay. Let's do this differently. Hit points is shield transform dot origin. So now we get a point near our shield, but without the necessary rotation. All right. Let's just see if this works. So this X-form inverse only does the rotation. I just want to see if we get a better value. So there's our error spam again. Oh, we were still running. All right. Let's see if that makes any difference. If it does, that means that there's a bug in our X-form inverse when there's a scale involved. Okay, still no cigar. All right. All right, I want to try this. Ooh, we hit it. I want to try this without that X-form in there. I'm just going to open the script without opening the scene. So that means that it shouldn't, or that should mean that it isn't started now. So we're gonna leave the X-form out of there. Instead, what we're going to be doing is we're going to do hit points is hit points times 0.1, because we want to, actually that is probably not correct. So we should probably do, oops, divided by shield size, because that is eventually what our scale is based on. And I'll look up that Godot issue in a minute and see if that is indeed so. Okay. All right, so we can see that now our effect works. Just our location is wrong, and that's because we're not rotating now. All right, but our effects works. All right. One thing that I want to do as well, just for now, we have to remember to undo this. And that's actually going to be over here. I'm actually going to put our damage to 1. I don't want to break our shield so quickly. We're going to put that back to 10 later on. Okay. No, not projectile. Fenderful. All right. So the workaround for fixing this. God, this is ugly. This is really ugly. However, this should be a function called orthonormalize, and this will take the scale out of our basis. So that will return a basis that is orthonormalized, taking scale out, and then we're using that to rotate, and then finally we apply our scale manually over here. And of course I've got a space here that I shouldn't have. So let's see if that does what we wanted to do. Not quite. Looks like it's doing it exactly the opposite side. That's really weird. Okay. Are we subtracting the wrong way around? That might be our problem. I think I need to do this the other way around. Let's have a look. I'm putting my headset on so that I can have a bit better and clearer view of what it is that I'm doing. And again, we're just going to keep on shooting our friends. Our friends must be really pissed off with us by now. Ha! One laser bolt hit one ship and the other hit the other one. Oh, I missed. Okay. I think it's hitting it at the right spot. It's a bit hard to see. I think I'm going to put the cull mode off for a sec, because it's really hard to see whether I'm hitting the back or whether I'm hitting it properly. Obviously, if I'm hitting the back, that means that our... Alright. You know what? I have a better idea. And that will take the guesswork out of this. When we look at our... Where are you? NFO. Our shield is always positioned at 0. There's only the scale is applied. So if we use the transform of our friend or foe, we're always going to get a unscaled transformation. So instead of using our shield transform, we're actually going to use our ship's transform. I'm actually going to make this shorthand. We're just going to take our global transform. That means we can now do this, but this will now be an inverse transform without a scale applied, which should work. Which means that we still need to do our division by shield size. And we can keep our test logic in there. Now the other thing that I want to do, and again, it's going to error spam. That is really annoying problem, but I'm not too fussed by it. The other thing that we're going to be doing is we're going to go and take that out. We're going to go and remove our cull disabled. Okay. And the reason I'm doing that is I want it to be easier to see whether we're hitting the back or whether we're hitting it properly. There we go. All right, I think we are. Yeah, we're definitely from time to time hitting the back. So why is that? That is so weird. Why? Is that because our position? Okay. This one's interesting. Why is this one so big? 1, 2. And after that, they're all fine. That makes no sense. Why is the projectile so far away from that? I'm thinking that the problem that we're having is that I've underestimated my issue with the size of the projectile. So I think that when we are hitting our shield, our projectile is now moved forward. And it's probably already far enough behind the shield to make a difference. And the reason why we're seeing such a big difference here, while it becomes smaller at the end, is because we're moving faster. And what we've done is to compensate it if we're moving fast, that we want our projectiles to always be moving faster than us. We've taken our speed and we've added the speed that we want the projectiles to have to our own speed. So the faster we're moving, the bigger our collision shape is, the more likely it is that our point, our location point of our projectile is actually behind our shield. Which really means that we need to start looking at how can we figure out where exactly we've hit our collision shape. All right. I did not know that. Nope. I removed a little bit too much there. Oh, that's a nice one to know. Always handy. Okay. So our problem is that we are going to need to calculate a much more accurate position here for hitting. How are we on time? We're almost out of time. Or find some other way to figure out where we have hit our body. Okay. Are we going to make our own intersection test for this? Which I really don't like doing, but okay. Alright, that's actually going to be interesting as well. Because I think in our missile, okay. Okay. So we're going to go and keep track of those two. Yeah, you can keep complaining about that because I'm not ready with that yet. current position. So we're going to track those 3 in here. There we go. Which now means that over here I can take these out, and that probably means that we're going to get current position complaining somewhere. That is in scope now, but yeah, probably need to reload this file. Close, reloads, which is declared in current scope because it is declared in our projectile, our last position. Oh, that is why, because this thing okay, so actually I don't care about this. There we go, we do care about that one. There's no point because we got our last position, there's no point in using our new position. Okay. So that's now figured it out. And then in here, we don't actually care about that because this can now become last position. Because that is now our new position. Same here. You know what? Let's make our life a little bit easier. Make a remark here. And that's just to make it a bit more readable, because last position would always indicate that it's from the last frame, but at this point it's no longer from the last frame. We've already updated it to be our new frame. All right. Cool. Let's see if everything still works or if we've broken something. That's still working without errors. That's good. And that's also working too. Okay, cool. Sweet. All right. Now I've done all that work, and I just realized that is that enough? We're gonna use our physics engine directly. I haven't done this for a while. We're gonna make our physics engine do the work for us, but we're going to write our own physics query. And for that, we're going to cheat by having a look at our add-ons. OpenVR, no, not OpenVR. XR tools. And we're gonna go have a look at our teleport because I do it in our teleport. And this is a while ago since I've last done this. Here we go. All right, let's copy this in first. So when we want to do work directly on our physics engine, we need to get our physics state. So we call our physics server and we first get our physics space for the object that we're currently working on. So that's our self.getRid. Rid is an internal numbering system, an internal way of managing resources. So that tells the physics engine who we are. In this case, our projectile. We don't really care about that because we just want to do a raycast. But I need to have these values. And then we're getting a state, and that state object allows us to do things. Now, we may not need the query, because I think the query is for more complex things. Because the one that I want to do is somewhere over here. Let's see, where are you? Intersect ray. That's the one. So, and we're going to go do our intersect ray from a start position to an end position. And we're going to see what that intersects with. All right. So we don't actually need a query here. Instead, what we're going to be doing is we're going to go, and we're actually going to take a longer piece to check this with. So on our state, we're going to call intersect ray. And now we're going to go and say last position, which is now our new position. And we're going to take away our delta position. So that gets us back to our previous position, but we're in the middle. So I actually want to multiply that by 1.5. So one of the things that we did, and this is potentially a bit overdone for our missile, because we're not actually doing this with our missile, I think. Not sure. But because we've made our collision shape longer and we centered our collision shape, so we've traveled from halfway in our collision shape to halfway our next position. So I want to go back to this, but I actually want to go back further. And we're going to cast our ray to the other side. So I'm actually casting our ray over a larger area than we have currently traveled. Now, one problem that we have with this is if we just skim the outside of our collision shape, then our ray is actually going to pass right by our collision shape. So we could have a situation where we're not hitting. Now, if that is so, we're actually just going to hit the shields with our global transform origin. So what we're doing here is we're checking whether we actually have nothing. Intersects is empty? Empty. So if we didn't intersect something, all right, sweet. All right, and I'm actually going to pass that location here as well. You know what we're going to do is we're going to make this a variable, say collision location, and we're going to default that to our global transform. So location, that's not going to autocomplete until we fix our typo or our incomplete code here. So we're going to default that to that, which means that I just want to come on, work. So if it's not empty, I don't know if there's a function that does the opposite there. Here we're just going to go and update our collision location, and that is going to be intersect position. There we go. Now, what we could do, I guess, is instead of using intersect ray, is we could be calling intersect shape and use our projectile shape, and that would probably give us a little bit more info about it. I'm not quite sure, but that's I'm not sure. That's something that we might want to experiment with a little bit more. So the reason I wanted to do it like this is because now that I've updated my collision location, if we find a intersection ray, is I actually want to send that to die as well, so that we have our particle effect at the right location. But that's okay. Unity is still a trash to develop a clean game. I'm imagining Godot. Yeah, I don't look at it that way. I think you need to develop in the game engine that agrees with you the most, and that is a very subjective thing. Some people really enjoy Godot, like me, and some people are more comfortable with using Unity, and a lot of that has to do with... Oh, I am stuck with my cable. Come on. There we go. A lot of that has to do with, you know, what you're good at. Whether you're good at C plus C sharp or something like that. All right, there we go. So try out all engines, I'd say, and decide which one fits you best. Oh, I hit my carrier ship. That's not good. I'm all dizzy now. All right, let's see. Oh, look at how much more accurate that is. Ah, that is super cool. And here you see when I really rapid fire, because we are shooting 2 bolts at the same time, you can see that 5 starts to become too little. Now the other thing that we right now have, especially with this guy, is... Yeah, let's go and fix our collision shape for our particle effect as well, or our location for our particle effect. I think that's actually a good idea. Now this is going to be a little bit more interesting. Find in files. Because we need to find all of the places where we're doing this. All right. So. And I actually want to make sure that we're just using whole words. Find. Okay. All right, why did that not go where I expected it to go? So, okay, hold on. Projectile. We've got a die false. Let's go and look at our base function here. Where is our die base function? Die. Doesn't take anything. Oh, that's because we have a die on our projectile. Okay. Cool. Sweet. So this is now going to be did timeout, and then hit. No. Collision. Point. This is vector 3. All right. Let's copy that. Now here we have a die true, where we can just send through an empty one, because that's not gonna... Actually, no. In this case, we want to use global transform origin. There we go. Sweet. Then we have a false. Here we're going to go and send through our collision location. Did I call that? Yep, collision location. So we're sending the right thing through. Then now in our missile, do we have a so message false, da da da. So what we actually want to do here now, no, that's that. So if we do our explosion, we actually want to go and change our location. What do they call it? To our collision point. So we want to make sure that our we adjust the position of where we're exploding, where we're doing our explode animation, to where our collision point is, instead of where our missile was at that point in time, which could be kind of off. So the same for the laser beam, exactly the same. Global position, and of course, if we don't know that, global transfer. I always get that wrong. Boom. And again, when everything's moving, it's not gonna be very apparent that that's what we're doing. And that's our friend or foe. So I think that will do what we wanted to do. So let's have a look if our particles, once we take the shield down, are going to be in a more predictable location. All right. Cool. So again, we're going to go and we have to hit this guy quite. Oops, I hit you. My shield hit their shield. Okay, I'm inside of him now, and I can't hit him anymore. Alrighty, let's go and flip around. Okay, who was I shooting at? I think we need to up the damage value of our. There we go. So yeah. Okay, so when we're too close to our enemy, we're actually shooting through our enemy, which is kind of interesting. Where are you? There he is. So you really pushed him away now. But you can see that our particles make far more sense where they hit. Okay. They do have quite a punch. Even though they don't do a lot of damage anymore. So let's fix that up first. Let's bring that back to 10 so that we can actually shoot things down. Beep might not beep. Why? Is the sound a bit too loud? Let me know, because then I'll turn the sound of the game down. All right. Let's go shoot some enemies. Okay, I have no idea how I hit that guy from that distance. I think there might be a little accuracy problem with... Gotcha. Unless I'm really a good trick shot, that's of course always possible. Alright. See if we can get this guy with the missile, see if our missile still work. Worried that we would overshoot him. No, I don't think we're going to get this guy with the missiles. My AI is, in that respect, a little bit too good. Do we still have a missile left? Ooh, that was very loud. Alright. Oops. I think I'm out of missiles right now. No, that was my last one. I don't know where the other two guys are. It's a bit of a shame because we've made our enemies fly around now. It's a bit harder to hit them with missiles. Now, where are the other two guys? Where did they go? They should be flying around here somewhere. I bet you they're going to start attacking me in a minute. Alright. I don't know where our other two enemies have gone. Unless our missile suddenly figured out where they were and all those blind ones that we shot actually ended up finding them. It's not impossible. Well, they could also be all the way at the end of the star field here. I don't know where our other two fighters have gone to. Well, I'm not going to go... Oh, wait, did I see something? No, that was just a star. Getting into shadow all the time is really annoying, actually. That's why you're flickering. That's because every time we go into the shadow of one of these asteroids. Yeah, shadow maps are working. But I have no idea where our other two enemies have gone to. Alright. Interesting. I actually want to go and just restart this one more time. And see if we can stay at a proper distance from our enemies so that they don't try and attack us. But we can actually launch the missiles to them. Where are you going? Okay, I think there's... There you go. Oh, it did hit him. That was pretty cool. I'm sorry for the annoying beep. I really need to have a better sound for that. Oh. Definitely hitting them. Ha. Oh, he hit the other one. He got in the way. Yeah. Oh, and they're starting to attack me now. Okay. Wow. Really? Well. Space fighting is so much fun. Okay. Let's get the hell out of here. Whoa. Oh, there's my other two guys. They're now having 4 guys trying to attack me. I really need to keep 1 or 2 of these guys stationary so we can actually do some practice on them. Because the thing that I really wanted to play around with... Whoa, that was way too close. Well, I am getting them, but that's about it. Oh, that was pretty good. I think... Oh, he's shooting at me now. Really? You're shooting at me now. And he's dead. Ah. Where's the last one? Where are you, buddy? The shield. Alright. The problem is that they are way too good at turning. And this is where you just keep circling around each other. And that's one of the things that I really need to improve on the ship AI. Just try and get them to fly a bit better. Anyway, there we go. So the principle is all working, and that's the thing that's important right now. So the things that we improved right now is actually let's do this. Let's do this because let's go to our test scene because I actually do want to show this off because one of the things that I've done differently is when we look at when we look at this guy, all he has right now is just a box. So if we start shooting here, we'll hit him, but we will also see our animation, our little particle effect somewhere out of space instead of on our enemy. But with our enemy, sorry, on our friendly. But on our enemy bomber, I've actually created a couple of collision shapes so that it's more close to our actual object. So the moment that we take our shield out, we should be able to shoot different parts of our enemy ship. But of course, if we're in a dogfight, like we just were, it's nearly impossible to keep track of that. So what I want to do, just as a last thing, just to show how everything works that we've done so far, because we are out of time. So this is the last thing that I want to do before we have a final little discussion. All right. So we're going to add another bomber to here. There we go. And he's just going to be stationary. He's not going to have any path assigned. That's a good one. I actually even don't want any state on this guy. So I want to make sure that that guy isn't doing anything now. He might end up still attacking us. I'm not quite sure, because I think we introduce a new state when we get close. So we'll see what happens. That guy might get into some interesting trouble. We shall see. We shall see. We shall see. Is he going to try and fly to me? No. There you go. We got a shield off. So that's where I hit actually on the side. As you can see, we can actually... eventually we'll destroy this guy, unfortunately. Boom. So yeah, that's really what I wanted to show, is with just a couple of very simple collision shapes, which kind of fit our enemy, instead of using convex polygon shapes for collision shapes. We can still create this effect that it looks like we're actually hitting him pretty closely on the body, even though, you know, the form is still slightly bigger. It's good enough, especially, you know, right now the only reason, or the only way that we can really test it, you know, I would have to dial down our values again. So that we could hit him a lot more to really test it out. And that's where you would see that we would even be able to hit him over here, things like that. But yeah, when we're actually flying around and we're in, you know, like a dogfight, you won't notice. You don't have time to watch if it's exactly hitting it in a correct spot. So even, you know, even a collision shape that's way off, like we have on our friendly ships, is kind of good enough for what it is that we're doing. And as a result, our performance for our physics engine is going to be able to handle these sort of things just fine. One thing that I do want to do at some point, which I don't think I've done yet, is that as the shield is up, is actually disabling the collision shapes of the fighter. Because again, that's just a waste of extra checking. So we can improve on that sort of thing. But those are just the sort of things, the sort of optimizations we do at the end when we really find that there's a need for it. I think that there's already a lot of optimization to still be had by making our asteroid field more efficient. Because I think that's where the bulk of our physics engine's time is spent. So, and the same actually for our projectiles and things like that as well. You know, everything, you know, especially like the lasers. You rapid fire them, that's quite a lot of collision shapes flying around. So those are the kind of things where you gotta wonder whether there isn't where it isn't better if we have a more simple solution for something like that. But we'll see. Anyway, all in all, we are now hitting our shields properly. We're getting our shield effects. Now we run out of time to actually do an effect for knocking our shield out, and an effect for reigniting our shield for when our shield is recharged again and comes back online. That I think is something then for next week. So. Hi Miguel, how are you? Yeah, I've answered that question a couple of times during the past couple of streams, but I'll reiterate on that one again. The project itself, the long-term plan is to turn this into a full game that I want to sell, and as such will contain assets that I will either commission or that I have bought online, which I just can't publicly share in that way. That said, as far as I'm concerned, the source code is something that I do want to open source. Obviously, everything that I write here on stream, I'm already showing. It's, as far as I'm concerned, all public domain. So whatever you see me coding here, you can copy. But making the files available is something that I'm still looking into the best way forward. Again, the problem that is that I don't want the project as it is right now, and especially once we start building much more of the game, I don't want that to be available as is because of all the assets, because of all the story content that eventually will be in there. That is something that I don't want to share. So I'm thinking at some point in time that I will make a repository that just contains the code side of this. So it will be a non-working project. But I'm still contemplating what the best way is. Obviously, a lot of the stuff that I'm doing right now also ends up in the tutorials that I do, and those project files will always be available. So yeah, I'm still weighing my options of what is the best way to make the code available. That's also one of the things that I'm thinking about tying into my Patreon and saying, maybe making builds available much sooner on to patrons or something like that. I'm not sure yet. I haven't made up my mind. But in the long run, yes, I do want to open source the code side of this project. And again, as far as I'm concerned, it is already open source. I just haven't made it available because you can see me building it live on stream, so you can see the code that I write, or 90% of the code that I write. But yeah, at some point, I do want it to be downloadable from somewhere. I just need to find the best way to organize that. All right, so. All right, that was fun. That was a lot of fun, to be honest. I hope you guys enjoyed it as well. Obviously, when you look at something like writing a shader like this on stream, from scratch, I'm sure we can do a lot better. I'm sure it can be made a lot better. It's just the first thing that came to my mind of how to build it. But it's a good start. So yeah, for anybody who wants to have another look at it. So yeah, just calculating the distance for each point. We have up to 5 hit points that we track. Again, I think this is mostly a limitation of Godot in the way that it works with uniforms. I do think you can have arrays as uniforms, but I don't think Godot supports that. But I could be wrong. But I think in the long run, I want to change the way that the hit times work. I'm not happy about that solution, but that was the like we discovered during the stream. That was just the quick and dirty way to get it to work right now, because we couldn't get access to the time value inside of GD script. Oh, I do want to re-enable this, by the way. Now that works properly. Let's do one more demo. I want to see how that looks in game. Now that we have the back culling turned off again, so we should see the back of what we're hitting. All right, let's go have one more last look. So yeah, so the idea that I have you know, to improve this at some point in time. Okay, that is not backcalling at all. Did we not save it? I actually also want to take out some of this logging. So that's now good. Unshaded coal disabled. I'm not sure why that... maybe because I still have these things open. Sometimes it caches stuff that it shouldn't be caching. So let's go and get rid of that. What's that one now? And we need to go into vendor help. Here we go. Just get rid of this stuff. So yeah, that's the other fun thing is having problems with that transform not working properly. So that's an interesting inverse transform bug. Whenever you scale, it no longer does the right thing. To be honest, I am not super surprised about that. Because it's something that is often overlooked when testing something like that, because you don't scale stuff that often in that way. So let's see. Yeah. Okay, so why is my backcalling not working? Or is working, I should say. These guys go fine. No. Okay, I don't get it. So, well, that's something I'm not going to solve tonight. Because for some reason it looks like on some hits it goes all the way around. I wonder if it's a timing thing. Whether the effect just ends too quickly. But it looks like sometimes it is backcalling and sometimes it's not. Well, it should always be... Oh, the other thing that could be... That is why. We need to turn off writing to the depth buffer for this thing. So the problem is, if we render the back of the circle first and then the front of the circle, it works the way that it's supposed to. But if the front of the circle gets rendered first, the back of the circle no longer gets rendered because we've already filled the Z buffer with higher numbers. So while we want to check the Z buffer, we don't want to actually update the Z buffer when we do this. So that's on the canvas item. You need to go all the way up. Where's my list of render modes for... Here we go. Shader types, spatial, render modes. So we do want it to do a depth buffer check, but we don't want it to write to the depth buffer. So we do want a test enabled, but we don't want to draw. Okay, where is my... And again, this is something that you only want to do with transparent shaders. You don't want to do crazy things like this with opaque shaders because you get the inside drawn over the outside at that point in time. Ivan Van, you are more than welcome. I'm glad you are enjoying it. Alright, this is hopefully our last test to make sure that this is now working properly. No, still not. Alright, what I wanted to see, I've probably already hit it too many times. But just to see whether my... Oops, missed. And I already had the shield down. That's a shame. Alright. So that guy is now not Going all the way around. I just want to see if my conclusion is right, or whether... Yeah. That looks funky. I wonder what's happening there. So this guy's looking fine. So there we can see that the whole effect is full. So I don't know. I'm not sure. Maybe it's because we... I shouldn't blow these guys up so close by. That's way too loud. I don't know how that sound is for you guys, but that was very loud in my ears. Okay. So that's something to work out a little bit further. I'm not quite sure why that is going wrong between those. The only thing that I can think of is that it has something to do with the fact that we are instantiating this the material multiple times, and maybe that it is getting confused between them. That's the only thing that I can think of. But we could see that on the first on the bomber, on the enemy bomber, it wasn't working properly. We couldn't see the back faces. And then on the first friendly that we shot, had the same problem, but the second one seemed to be drawing properly, even though it's all the same shader with the same values. Now, the other option that could be throwing things off is the fact that we are using the whirly texture as a texture that's generated through your viewport. So that is definitely something that I want to change. I'm going to write some code during the week just to allow me to save the whirly texture to a PNG, and then we just use that PNG as the texture for our shields. I think that's going to be far more efficient than what we're doing right now. So yeah, a few more things to figure out that aren't working completely perfect, but in a whole, I think the effect is pretty cool. I think the yeah, we can do some nice things with this. Now, obviously, right now it's all done with a sphere. So one thing that I do want to do at some point in time is to experiment with more complex shield shapes, and with that also more complex shield collision shapes, and see how well that works. But it should, it should work regardless of the shape of our shield mesh. So if we use a cube, it should still work. Or if we use, if we use a form that form fits the actual the actual ship, it should still work. And that's something that would be nice to experiment with. But as a start for this, to actually get the shields to do something when we hit them, to get some visual feedback that we're actually shooting the shield down, I think that's a good start. We got some cool logic running. I think we're going to continue on this next week and look at making some sort of effect, like I said, when we take the shield down, instead of it just disappearing, we actually get some animation of it disappearing. And the same thing with it, coming back up. So that's something that that we haven't had any time for yet. But we're going to start playing with bringing the shield back up. So, I think that's it for tonight. So unless anybody has any more questions, we'll give it another minute or something. And then I think it's time to sleep, because it is 12:30 for me. So yeah. Again, I hope you guys all enjoyed this. I hope to see you again same time next Friday. Anything else that I can show off while we wait? I need to work on some more weapons, I think. So the S's that we got so far. Thank you for being here, Soundsbeard. I'm glad you enjoyed the stream. That was just a console. Yeah, logic. Yeah, the other thing indeed is having a look at our coordinate system to not get that squishy effect at the top. That's just a matter of making the texture that we use a little bit smarter. Because of course we need to make sure that our UVs are wrapping around as the wraparound texture, a tileable texture. It's a bit harder with spheres. That said, you know, keeping it this way is not too bad either, because it's sort of gives the idea as if the shield is being emitted around our ship. But yeah. All right. I think that is where I'm going to leave it, guys. So again, thank you all for watching. And I hope to see you guys next week again. So good night, everyone, and see you guys next time.